How's it going, guys? Hello. We're going to look at 3-2 today in our topic 3 packet, which 3-2 is all about translations. And so we're going to talk about what does that mean. Last time we looked at reflections, and so today is going to be just the next transformation that we're going to look at. So we have three objectives today. By the end of this lesson, you will be able to translate a figure and write a rule for the translation. You're going to find the image of a figure after a composition of rigid motion, so multiple rigid motions. And you're going to prove that a translation is a composition of two reflections. So that's what we're looking at today. There is two new vocabulary that we're going to look at. Translation, right? That's everything that we're doing today in this video is all about translation, so we should probably know what they are. And then we're going to look at a composition of rigid motions. So I'm going to have you go to the back of your packet where all those terms are so that we can fill in our two new vocabularies for the lesson. Okay, so here's our terms page, and we're going to go down to these bottom two here, translation and composition of transformations. So we're going to start with looking at a translation. What is a translation? So a translation is a type of rigid motion. Remember, rigid motion means that the shape and the size don't change. Okay, so we're just sliding or reflecting or something like that, but the shape of it and the size of it stays the same. That's my dogs. Sorry. So all we're doing in a translation is taking an image and sliding it to a different position. And so it's just a slide. Okay, so we're sliding the same distance and direction. Every point gets slid the same distance and direction. Meaning if I have just any shape, there's a little heart, right? I can slide this in the same direction and it's just moved, okay? And you can translate any figure and you can translate it in any direction, okay? When we write translations, the rule is we use a capital T, which means translate. And then we use these triangular brackets. And there'll be one number here. And that number is your horizontal distance. Horizontal distance. So how far left or right are you moving? Okay. And then whatever the second number is will be your vertical distance. How far up and down are you moving? Okay, so if it's positive, you'll go up. If it's negative, you'll go down. Just like with the horizontal, if it's positive, you go to the right, and if it's negative, you'll go to the left. So that's how we would write our translations. So again, translation is just a slide. You're sliding something from one spot to another. Okay, the composition of transformations is when we're combining two or more transformations. Remember that we have 4 different types of transformations: reflection, translation, rotation, and dilation, okay? So it's a combination of 2 or more. So it might look something like a translation, right? Here's what my translation will look like. And then it has a little open circle like so. And then it might have a reflection, which is a capital. And oops, and the reflection, the parentheses were down below, just like the brackets. There we go. And what's special about this is that you do the one that's written second first, which I know is super weird, right? So you're going to do this one first. So whatever is written second, so in this case, I would reflect first, and then I would translate. So I would reflect first and then translate. And we're going to look at a lot of different examples of this, so don't stress out too much. But the only thing that we just really need to know here is that whichever one is written second is the one that we do first. And those are our only two terms for the day, so not so bad. We're going to go back to our section 3.2 notes, and we'll look at how to do some translations. Alrighty. All right, so we're back with 3-2 in our first example, which it's asking me to find the image of a translation. So it says, what is the graph of the translation 7, -4 of triangle EFG, which equals E prime, F prime, G prime? So there's a lot of stuff going on in this problem, so let's talk about it first. Capital T tells me that it's a translation, which is a slide. Okay, the 7, that's my horizontal distance. And since it's +7, that tells me that I'm going to move every single point to the right 7. So 7 units. And then the -4, because it's written second, that's my vertical change. And because it's a -4, we're going to go down 4. Okay. Now it's telling me to do that to triangle EFG, which is right here on the right. Okay, so it's already drawn for us, which is nice. So I'm going to take every point and I'm going to go right 7, down 4. So from F, I go 1, 2, 3, 4, 5, 6, 7, and then down 1, 2, 3, 4. And I'm going to draw that point and I'm going to call it F prime because it's the image, right? I've done something now to this triangle. I'm going to do the same thing with E. 1, 2, 3, 4, 5, 6, 7, and then go down 4. 1, 2, 3, 4. It's going to be E prime. And then G, I'm going to go right 7. 1, 2, 3, 4, 5, 6, 7, down 1, 2, 3, 4. And there's G prime. And I'm doing my very best here. And there is the graph of E prime, F prime, G prime. And that's it. So it's really just learning how to read this rule, right? The first number is my horizontal distance. The second number is my vertical distance. So I'm going to clear this one, and I want you guys to try the next two on your own. Okay, so here they are. What are the vertices of E prime, F prime, G prime for each translation? So it tells you what the translation is. You're going to graph it and then write down what are the vertices. Okay, so go ahead and hit pause on the video and give it a try, and then when you're ready to check your work, hit play. Okay, so let's check our work here. The 6 tells me that I'm going to go to the right 6, right? And right 6, and then the -7 tells me I'm going to go down 7. So I'm going to show you two different ways that you can do this, okay? The first way is just to graph it. So I'm going to go right 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Call that F prime. E right 6. 1, 2, 3, 4, 5, 6. 3, 4, 5, 6, 7. It's going to be E prime. And then G 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Doesn't quite fit. That's okay. We can make it work, right? And there's G prime. And then I can just find the coordinates. So E prime is 1, -3, right? Because it's asking me what are the vertices. So I have to actually write down what are the coordinates. F prime is 5, -2. And G prime is 4, -8. So that's one way that we could have done it, right? Just move all the points over. Another way that we could have done it, and only do this if you actually feel pretty confident in it, right, But we can look at just point E, which is negative 5, 4. F, which is 1, negative 1, 5. And then G, which is negative 2, negative 1. Okay. And what I could do is just add 6 to the first number and subtract 7 from the second number. And that is another way that I could do it, right? So negative 5 plus 6 is 1. And then negative 7 plus 4 is negative 3. Okay. For F, negative 1 plus 6 is 5. And 5 plus negative 7 is negative 2. So hopefully that's making sense here. Negative 2 plus 6 is 4. And negative 1 plus negative 7 is negative 8. So that's another way that you could have done it. So you can do this even without graphing, which is kind of cool. So let's look at B. B looks like I'm going to the right 4 and up 2. Right now that 2 is positive, so right 4 up 2. So 1, 2, 3, 4, 1, 2. So here's F prime. 1, 2, 3, 4, 1, 2. Here's E prime. And then 1, 2, 3, 4, 1, 2 is G prime. Make sure that you're putting those primes in, right? Because you need to know which one is your pre-image and which one is your image. So E prime, I can do the same thing that I did before, right? So E, or I can just look at the graph if I want to graph it. But remember, E is negative 5, 4. So if I want to know E prime, I would add 4. So negative 5 plus 4 is negative 1. And then add 2. 4 plus 2 is 6. And if I check, E prime is at negative 1, 6. So that's right. Okay. For F, I do negative, that's the original point, negative 1, 5. So if I want to find the new point, I add 4. So negative 1 plus 4 is 3. And 5 plus 2 is 7. And so if I look, 1, 2, 3, 7, there's F prime. And then the original point for G was negative 2, negative 1. And so if I add, there we go. If I add 4 to negative 2, I get 2. And if I add 2 to negative 1, I get 1. And that is where the point is, 2, 1. So 2 different ways to find the coordinates. You do not have to do both unless you're dying to, okay? If you want to just graph it and then find the points that way, go for it. If you want to just add the numbers to the coordinates, go for it, okay? I'm not particular on which way you use to find those coordinates. So now let's look at going the other way, right? What if I'm given the translation? How can I write the rule? Remember the rule, what we mean there is just the T, right? And then the bracket, bracket. So I just want to know how far left or right did I go and how far up and down did I go. So what we're going to do is we're just going to find a point, so on the pre-image. So let's just do S. And here's S prime. So I'm just going to count. So S to S prime, I go left 1. So that tells me that my horizontal distance is 1, negative 1, excuse me. So I go left 1, and then I go down 1, 2, 3, 4. And since I go down, there's also negative 4. And that's the rule. And that's it. Okay. I didn't have to use S. I could have used T, right? Here's T and T prime, left 1, down 1, 2, 3, 4. They should all go left 1, 1, 2, down 4, right? Left 1, down 4. So you can pick any point you want, as long as you make sure you pay attention which one is the pre-image and which one is the image. Okay. Let's go ahead and I want you guys to try the next one. So I'm going to clear this, scroll down. Okay, try this one. What translation rule maps P onto P prime? So here's P prime. Take a couple seconds or so and see if you can figure out what the translation rule is here. And then when you're ready, hit play. Okay, so hopefully we counted here. I'm going from P to P prime, so I have to go to the right. 1, 2, 3, 4, 5. So since I've gone to the right 5, my first number is positive 5. And then I go up 1, 2, and again, since it's up, it's going to be positive. And that's my rule. The translation goes right 5 up 2. And that's it. Hopefully we're feeling pretty good about the actual just translating things. It's not so bad. You're just counting on the grid. What we're going to look at as our last idea here is the composition of rigid motions. So again, this is when we have 2 or more rigid motions that are moving a figure around. Okay, so this is an example of what something might look like. Here how do I say it? My pre-image is triangle ABC. Okay, so whatever that is, whatever triangle ABC is. Then the first thing I'm going to do is I'm going to translate this triangle left 2 units and up 5 units. So that's what I do first. Then I'm going to reflect that new triangle across line L, wherever line L is. So it's really just taking our time and looking at these step by step. And we're mainly going to look right now, we're mainly going to look at 2 translations together. Okay, so it shouldn't be too crazy here. So let's look at an example. Okay, so we're just going to focus on composing translations. So this is asking us, if I move to the right 3 units, down 2 units, excuse me, I said that wrong. If I move to the right 1 unit, right, because we have to do this one first, right 1 unit, down 1 unit, and then I move right 3 units and down 2 units, how far did I go in total? So basically what this means is that I have a point, let's call it point P, right? I go right 1 unit, down 1 unit. And that is the point P prime. That's my first translation. 1 unit, 1 unit. Then I move that point right 3 units, something like that, and down 2 units. And that would be the point P double prime. So when I do something twice, I can have 2 tick marks. And this was right 3 and down 2. So then the question is, how far did I go from P to P double prime? So I want to total, so let's write, right, translation. To the right, I want a total of 1 unit, but then 3 more units. So I want a total of 4 units to the right. And then on the vertical, I went down 1 unit, but then I went down 2 more units. So that would be -3 because I'm going down, it's negative. Again, the little trick, you can just add these together. 3 plus 1 is 4, and -2 plus -1 is -3. So 4, -3. Okay, so I want you to try the next 2 triads. One is a composition. Actually, they're both compositions, right? And I want you to see if you can figure out what this is, what the composition is. Okay, what the total is. So your answer is just going to be like this original one that we just did. So go ahead and hit pause and try those 2, and then when you're ready to go over it, hit play. Okay, let's check our work here. The first one says, what is the composition of transformations written as one transformation? So my answer is just going to be one transformation as such. Okay, well, multiple ways I could do this. I can just add these together. So -4 plus -2 is -6. And 0 plus 5 is 5, right? So that's one way. Or I can kind of sketch it out, right? Here's a point. I go, oops, excuse me. That is not right. Here's my point, and I go left 2, so left 2, up 5. This is 2, this is 5, right? And then I go left 4 more. And this would be like P prime, and P double prime. So the total distance I've gone is I've gone left 2 and then another left 4, so that's left 6. And then I've gone up 5, up 0, which is 5. Okay. And then the last chart here is a mover moved a box from A to B to C. What single transformation describes the move from A to C? So what's nice here is that I can find the translation from A to B, right? So from A to B, I translate left 1, down 2, so -1, -2. And then from B to C, I translate left 3, so -3, but up 1, 2, 3, 4, 4. So if I combine this translation, I get -3 plus -1, which is -4, and then 4 plus -2, which is 2. Okay. The other way that's faster is I just want to know how far it's from A to C. So I can just do that translation and not even worry about B. Don't even worry about B, okay? I go up 2, so that's +2, and then left 1, 2, 3, 4, -4. So you could have skipped B altogether. I just want to know what the transformation is from A to C, okay? Or you can combine them to find this. Okay, so hopefully we feel good. If not, make sure you reach out. We only have one example left here. This is not going to work very well for me in my drawing ability, but we'll do the best we can, okay? Okay, so example 4 says relate translations and reflections. How are reflections related to translations, okay? So this says, well, the first thing that we have to know is that N and P are parallel. So I'm going to make those little arrows. I know they are because 2 vertical lines are parallel, but just in case, okay? First thing says to reflect triangle ABC across line N. So I'm just going to reflect. So we got to think back to last video, right? I'm just going to count to the line of reflection and then count past the line of reflection. So 1, 2, 3, 1, 2, 3. And I'm going to call that point B prime. I'm going to do the same thing here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. A prime. And then here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, there we go. C prime. So then we draw our triangle. Just like so. Okay, and I've reflected it. So I've formed triangle A prime, B prime, C prime. Now it wants me to reflect A prime, B prime, C prime, so this triangle, across the line P to get double prime. So I'm going to do the same thing. 2, 3. Okay, but now I'm going to call them double prime. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so now the triangle is labeled double prime because I've done something to it twice. Okay, so that's my second image. And so now I'm going to connect this triangle. Okay, and it says examine and describe what happened in the transformation from ABC to A double prime, B double prime, C double prime. So if I take this out in general, you don't have to erase it, but just for us to look. Okay, what has happened to go from this triangle to this triangle? And hopefully we see that it's just a translation. I've just taken this triangle and slid it across the paper. Okay, so two reflections. Right, I reflected it twice. So two reflections over parallel lines is a translation. And that will always be the case. They don't have to be perfectly vertical lines. As long as the two lines are parallel, your answer will always be a translation. It'll just be a slide across. Okay. That's it for us on translations. Let me know if you need help on it. Let me know if something didn't make sense. Our next lesson is all going to be about rotations. So we're turning things, and so we'll talk about that in our next video. So reach out if you need help on this, and I'll see you guys later.